Hello, everyone. Thanks for joining in. I'm just going to take a minute and I'll wait for the rest of the people to join in and then we can start. All right, so I just want to check first. Can you guys hear my voice? Can you guys see my screen? Just for the sake of testing in here, just for us to understand if everything is okay. Is my voice clear? If you can just write it probably in the chat. Is my voice clear? Can you guys hear my voice? Can you guys hear my voice? Can you guys see me on the screen here? Can you just write in the chat just for me to understand if everything is okay? Can you hear it or you can't hear it? I mean, it's, nothing is. Okay, so it's clear. Fantastic. That's awesome. Thanks. Okay, so let us just wait for a second. We have, I think, 3 minutes, give or take. So we'll just wait and see if people are going to join in, then we can start. Okay, thank you very much. مساكم الله بالخير, مرحبا فيكم. I'll have to switch to English just to make sure that everything can hear me well. Okay. Thank you guys very much for joining in. I just want to know, can you guys still hear me? Can you guys still see me? And can you also see the screen as well? Can you see the slides? Can you just write in the chat if you guys don't mind, just for me to make sure before we go ahead? Perfect, awesome. Okay, so it is now 12:33 and I'm gonna wait for 2 more minutes before we start. So we at least stick to the schedule and we make sure everyone is here and they're not missing this. Okay, awesome. Are you guys excited? Any gamers in the house? Any game developers in the house? All right, okay. 1 more minute to go and then we can start. One more minute to go and then we can go ahead. Okay, so I'll tell you what, we can start. Go ahead now. Okay, awesome. Hey, Ahmed. No, actually, this is going to be one of my friends, Mohammed Ba'alai, who's going to be talking about that. But I do happen to be a Google developer expert also in machine learning, which is a huge coincidence. Okay, awesome. Okay, I'll tell you what, since I'll be managing this session, every now and then I'm going to have to admit people into the talk. So please bear with me here if I switch and add more people to the talk. However, we can go ahead now. Okay, thank you very much for having me here today. We're going to have a very cool subject today. It is called A Look on Reinforcement Learning for Games. And we're going to be talking about a specific division within games, especially within game AI, that goes by the name of reinforcement learning. To be quite honest, reinforcement learning is also attached to AI in general, specifically machine learning. It is not only solely exclusive to game development. However, there's a lot of use cases when we're talking about game AI and such. So we're going to go ahead. We're going to have a brief about how AI works in general and in games. And then we're going to make our way and we're going to ease into the subject of reinforcement learning. One last check before I go ahead. Can you guys see my screen? Can you guys hear my voice? And can you guys also see my video? I need the final go ahead before I go ahead. Are we good? Perfect, awesome. Okay, so this is the subject that we talked about it just a bit now. So a bit about myself. My name is Ameen Altajer. I'm actually a Google developer expert in machine learning, which is a very huge deal apparently in Google. We're only 150 in the whole world, and you get to be interviewed by folks in Google. And this is a Google invitation program only, where they get to interview and do the whole thing. You don't get to apply for it manually. So this was really, really great. And I've done a lot of work in cybersecurity and blockchain and machine learning and a lot of places also. But my main expertise is artificial intelligence. I've been developing games for a very long time, and this has been super, super great. And yeah, you can probably check out my work if you want on ameenaltajer.com. And you can also check out my profile at Ameen Altajer, be it on Instagram and Facebook and even Twitter if you're interested. Now, my business is also called INFINITEWARE, where it's basically an AI business, an artificial intelligence business, the first one in Bahrain, and we have a very, let's say, prestigious set of clients that we're really proud of. To get you just a bit of an insight of what we have in our portfolio, we have Saudi Aramco, we have STC, Zain, the Ministry of Interior also, and a couple more in banks and a couple of institutions as well. So there you have it. If you're interested, you can always check out our work at infiniteware.com and check out how we do our work here. Okay, perfect. One more thing, since we're talking about artificial intelligence, one of our products that is really a bestseller goes by the name of Kavria, which is a chatbot. But this twist is it's an internal chatbot, which means you can deploy it in organizations, and they can benefit from having that chatbot experience without going to the internet. Now you might wonder, and you might say, is that really necessary? To be quite honest, yes. In government, let's say, and a lot of organizations like banks, where they don't really have a lot of love, let's say for cloud in general, they prefer to have everything in-house and within the organization. And Kavria really helps with that. So this is really, really great. It keeps learning on its own. So if you have, let's say, specific jargon being thrown in your organization, it can pick it up on its own. It's going to use its AI magic to pick it, to pick those nuances. And it also works on mobile and on desktops. And it's not a solution on its own. It integrates with all the IM solutions that we have. So if you're running on Microsoft Teams, for the sake of example, you can also just integrate it and get that sort of intelligent, let's say, personnel working for you that are AI based, which is really great. All right. Okay, now that is out of the way, we can go ahead with the main subject. Now, the million-dollar question is, what is AI? And what is AI in general? What is it? And let's just keep the hype away, and we want to really dig down and understand what AI is in simple terms, of course. Now, if we're talking about artificial intelligence, it is just straightforward. It is the subject of giving some of our intelligence, that we have in human beings, and give it to our metal friends. And I like to call them metal friends because we're talking about computers here, we're talking about programs, but in general, it's all about giving some of our cognitive skills. And this is funny because we think as human beings that we are the best species in the world, as far as we're talking. I mean, until now, maybe yes, but this is highly debatable. And you can go ahead and argue with me if you want after this talk. And it's going to be interesting. But in general, we as human beings, we believe that we are on top of the food chain pyramid. And we are basically the species that have the highest levels of cognitive skills. And so things like learning, problem solving, just understanding the world, understanding pattern, computer vision, let's say audio skills, and all of these things, auditory skills, and every bit of those skills is only exclusive to human beings. This is at least what we think. And so the million-dollar question is, can we bring some of those skills and put them in our metal friends if we're talking about computers? So basically, this is what AI is all about. And it might seem that it is really an easy feat. However, it is a complicated feat. A good example is the idea of computer vision. Now, computer vision, a lot of people believe that is just a very easy thing to begin with. However, there's a lot of research happening in computer vision and even in voice synthesization and all of these core skills that we believe and we work with as human beings. And we just take it for granted that this is something that is just easy to work with. However, when you're trying to implement the same thing in machines, you begin to understand how difficult the job is. So it's not an easy feat. So now that you understand what AI is in simple terms, let's head into a much more specialized term in here. Now, what do we mean by AI when we're talking about game development, if we're talking about developing games? Well, here's the thing. If you're developing games, the twist is a bit different, I'd say. But before we head into that, let me just give you a map of the AI world so we can understand where we stand here. Okay, so when we're talking about artificial intelligence, you got to understand it is this huge circle, and there's a lot of techniques, a lot of stuff happening in there within artificial intelligence. So it's a very elastic term that gets thrown everywhere, be it in business, in science, and all of those places. But it is a lot of things. I mean, there's a lot of things happening in artificial intelligence. You have things like evolutionary programming, evolutionary algorithms, you have decision trees, you have so many things. And by the way, artificial intelligence is not new. This all dates back to the 50s. Okay, so think about it. So we're talking now about a discipline that has maybe a history of 70 years or more, but everyone's just going crazy now about artificial intelligence. And the reason is that now we have what we call machine learning. Now, machine learning also is not a new field. It is a subset of artificial intelligence, but we're somehow working with different things within the subject of artificial intelligence. With machine learning, the ultimate goal is to have this automated system that can learn on its own, which is, again, easier said than done. So with machine learning, we can rely on statistical models, statistical techniques in general to go ahead and pick up some of those nuances to add that sort of, let's say, learning field within our AI programs. And this has also been called classical machine learning because it goes back and there's, let's say, no advancement in that field. However, what has been happening super lately is the idea of deep learning. Now, deep learning is a subset of machine learning. And the magic is that we're relying on human biology in order to pick up the inspiration. Cool. So we're picking up on how the human brain works, and we're not replicating it 100% if we're talking about our new programs. We're just picking up some of the inspiration from there, and we're doing it on our own. You probably heard about things like artificial neural networks, ANNs, artificial neural networks, and this is all coming in within this area, which is deep learning. Now, this is brand new, and it's heavily dependent on data. This is why you hear everyone talking about how data is important and how it's the new oil in the world and everything. And that is really, really important and crucial because in deep learning, the ultimate requirement to have that sort of AI deep learning experience is that you have to have data to begin with before you chart into that journey. Cool. So there you have it. This is the map. So every time you keep hearing machine learning, deep learning, now you do understand how things fall into place. Perfect. And by the way, you can always pick up and put your questions in the chat and I'm going to address them down the line. All right. Okay. Now sweeping in again to our subject. Now, what is the deal with the idea of creating an AI for games? Is it different? Is it the same thing? It's completely different. Now, yes, we do share some of the, let's say, notions in there, which is the idea of creating like an artificial intelligent agent that can play with us in the game, you know, as an opponent for the sake of example. However, the twist here is when we're talking about games is that you have to strike, let's say, a balance between a lot of things. The first one is you want to make sure that your game is really fun to play. So what's the point of having a game if it's not fun to play? It's not a simulation in the very end. I mean, it is an experience that is joyful and it brings a lot of joy for the people who are playing the game. But in the same time, you also want to strike that balance of making sure that your contender, or in this case, your opponent, is a worthy contender. You want to make sure that they have, you know, a sufficient amount of intelligence where they can participate in that exercise, you know, to depict their intelligence. So, you know, they're worthy of your time, your experience, and your challenge, basically. So striking that thing is not an easy thing. Yeah. And everyone is talking about the idea of fair, you know, competition. Is it really fair when we're talking about, you know, AI agents? Are we really talking about fair contenders in here? Or is it just, you know, we have a simulator of some sort that just, it tries to give us the illusion, you know, that we're playing against an intelligent entity, which is, again, a very huge deal, to be quite honest, especially in this field. So striking that balance is not an easy job. And I want you to understand how difficult it is, you know, to think about that. You can come up with your AI agent, but if you can't strike that balance, if you can't put somebody who is, not somebody in this case, something that is super intelligent, you know, to depict that sort of behavior, that they are a worthy contender to the player, to the human player, but at the same time, you want to make also the game fun. I mean, if you can't strike that, you're going to have a very rough time trying to allow people to play your game and, you know, really get excited about it. Now, I also want to tell you that we got to the stage in game development where our AI work has been like hugely improved, like to the level that it is very difficult for people to understand, if they're playing against a human player or an AI agent. A good example is like the game of The Last of Us. If you ever played that game on PlayStation 4, The Last of Us, and this is what I really like about game studios, is that they're very open when it comes to sharing ideas about how they do their work, especially within the technical field, like within the technology that they're using within game development. So Naughty Dog, who that is the developer of the game The Last of Us, whether you like the game or not, shared a lot of details on the AI work that's being done under the hood for the game. And when you look into the paper and you look into the making of videos, you begin to understand the scale of the issue and how they really manage it super well by having really clever ideas to depict, the illusion, to make that sort of illusion that you're playing against a very intelligent, opponent. So this is really great, and we got to a level where this is super impressive, to be quite honest. Okay, now since we talked about a bit of AI and how it really works within the game industry, and to understand the distinction here in terms of goals and the things that we're trying to achieve, how do we begin understanding how it works from the inside? Now we do understand what is needed to be, what we need to achieve in terms of goals, but how do we really allow our games to leverage that sort of a thing? Now let's hit through it. So in game development, we're relying on something that we call heuristics. And the idea about heuristics, which is a very fancy word, but it means that you have game rules that are baked within the game. So imagine I'm trying to I'm trying to write an AI component for the tic-tac-toe game, or the XO, the very traditional game. What we normally do is we pick up some of the experience that our human players have, and we bake those rules within the game itself, which means that we have to have that sort of encounter with game players, human players who know exactly how to play the game, and then we try to somehow pick up on their experience and put it within the game rules. So this is what we call by heuristics, and this has been happening for a very long time. A lot of people have been really have been doing this again for a very long time, and it's been working for us, which is really, really great. So no problem in that. Yeah. And to give you an example of how that works in terms of logic, imagine you have that sort of, let's say, flow. Is the ball on the left? If it's yes, move the paddle. Imagine you're playing like a breakout game where you have a paddle on the end and you have a ball on the top. If the ball is on the left, move left. If the ball is on the right, go right. Yeah. If it's in the middle, do nothing. So all of that logic, as you can probably tell, is baked in here in that simple tree. So this is exactly what's happening within our games. We have a simple tree, we have a simple logic that we follow, in order to do that sort of a thing. And in game development, there's this sort of construct that we go back to every time, and we heavily rely on, that goes by the name of FSMs, which stands for finite state machines. And the idea is that you want to have multiple states for your game AI agent, and you just want to have, the AI agents to switch between those states according to the environment. Yeah. So we have states like chase the player, sit idle, attack the player, receive damage, die, and then stop or start, whatever it is. To give you a good example here so you can understand, where we're going with this. So this is a sample FSM for a very easy game. So let's imagine that we're starting from the top here, we're roaming. So your AI agents is roaming around, okay? And as you can probably see here from this arrow here, when you see an enemy and your health is low, which means that you're running low on health, start fleeing, which means just go ahead and try to run as much as possible, as far as you can go, so you don't get hit with that, with damage. But if the enemy is next to you and you have enough health, go ahead and start fighting. And then if you die, and you get killed, go back to roaming around after you get respawned. Or if the enemy is fleeing, just start to chase them. And as you can probably tell, this is very easy to translate because you have multiple states, and it's just a matter of going from one state to another depending on the environment, which is very easy to implement, by the way. If we're talking about code, it's just a matter of if and else statements. So if you're into programming, if you have done any work within Python or any of those languages, you'll understand that implementing this is not a difficult job, to be quite honest. But even though we're talking about FSMs here, FSMs are not the only solution that we've been relying on in the game industry. To get you a bit of sort of landscape here of what's happening, if we're talking about the deterministic kind, we have finite state machines. We also have decision trees, the thing that I showed you at the very beginning. And we also have behavior trees. We have also pathfinding. So we've got algorithms like A star, which is a very popular algorithm to find like a target location depending on the environment. So if you have trees in the middle, if you have barriers or walls, your AI agent is going to be able to go to a specific destination. You know, if there's a, let's say, a route to that place using the A star algorithm. So a lot of work has been done, as you can probably tell, from the deterministic division here. But now we are exploring other means of building an AI, you know, basically AI agents. We have what we call the non-deterministic kind, and that means we're relying on methods that are completely different from the deterministic kind. We're not putting our experience, just like what I showed you there in the heuristics slides, where we put the human experience there. We want to introduce a new experience where the AI agent can pick up experience on their own. You don't want to teach them exactly how to play the game. You just want to put them in the environment and let them learn on their own, as if they were, you know, human players. And to do that sort of a thing, we have a lot of methods, but namely we have genetic algorithms or evolutionary programming, and we also have neural networks, which is the field of machine learning, deep learning to be more exact, just like what I showed you in the map slide in the beginning. So this is a landscape, and it's not so small. So there's a lot of opportunities and choices that you can take when you want to build an AI agent. Yeah. Now, I'm just going to give you a recap on machine learning, on supervised learning for the people who don't understand what this is before we continue. All right. With machine learning, we have so many fields, you know, just like what I showed you, machine learning or even deep learning. Those two circles in deep learning within, we've got three fields. Not really three, we have more, but the three main ones are supervised learning, and we have also unsupervised learning, and we also have reinforcement learning, which is the main goal of this talk. However, if we're talking about supervised learning, it is getting super popular, and the reason is it is super applicable to fields that are spanning business, let's say. So things in banking, things like insurance, even cybersecurity, by the way. All of these fields can really benefit of machine learning, the supervised part. In a nutshell, what that means is you have a lot of data, and I'm going to give you the example of making the distinction between cats and dogs. So imagine we have photos of cats and we have photos of dogs. How can you build a program that can tell the difference between cats and dogs easily without really suffering that much when you're programming it? Now, if you're a programmer, you will know by heart that this is extremely difficult to program because there's a lot of variety. You have like a huge amounts of cats that have different colors, different shapes, different, I would say face shapes also. And so there's a lot of factors and a lot of variance when we're talking about that. Now, to do that sort of a job, that sort of a feat, in machine learning or deep learning specifically, the job is very easy to conquer. The reason is when you have a lot of photos for cats and another set for dogs, the only thing that you have to do is push those images through an algorithm that we call artificial neural network, which is again a generic algorithm. So just remember, it's a generic thing that you can use on and on and on and on in different things. And as you push that, so you know the sequences of images that you have from the data set, from the cats and dogs image set, when you push image by image, you as a human being, you supervise the process. So you told the machine that, hey, this is a photo of a cat. This is a photo of a dog. And you go on and on and on until you finish off your set list, yeah, of you know, the image set. And by the time you finish, the deliverable that you're going to have at the very end is what we call the model, which is, in a way, we can give that sort of analogy where we say this is the deliverable brain, where it can tell the difference between cats and dogs because it has seen so many images and examples that it can now tell the difference on its own. You don't need to, give it any code. You don't have to hard code this in F and else as a programmer. You can just show it images and it'll be able to classify exactly how to go about it, which is really beautiful because if you think about it, this is one of the most difficult tasks. And with the abundance of data, we can exactly conquer it. Now, this also can be applicable in a lot of fields. You can do it in cybersecurity, you can do it in government, insurance. It doesn't have to be, within that same example circle where we're talking about cats and dogs. Yeah, so this is supervised learning in a glimpse, which is so easy to work with. Now, the other field, which is reinforcement learning, is not as easy as it sounds, but it's making its way in games, especially game development, because of the perks that you can get, if you're working in that area. And the idea is very, very simple. So you have an agent and you give it an environment, and then you allow it to explore and exploit the opportunities that it has within the environment. So by doing an action, you get a feedback that, okay, this action is good. I might want to do more of that action. Or like if you get if you get damaged by doing an action, you get a punishment of some sort. So the agent would exactly know that this is a very bad action. I'm not going to do it anytime soon. So this is what we call reinforcement learning. And the idea that we call it reinforced is that by doing an action, you get a reinforced feedback. So you can enhance or exactly shape, the way you think about the environment. The funny thing for me, honestly, is that this is exactly how we're behaving in the world as human beings. So you do a lot of trial and error. So what works, you do more of it. And what doesn't work, you stop doing, to a great extent. So this is exactly behaving as if, this sort of paradigm tries to mimic exactly how human behavior is done and how it's operating in us. So this is reinforcement learning. And then now it is finding its way within games, as I said, to a great extent, and we're going to explore that. I want you to remember within reinforcement learning, the idea is fairly simple. You want to explore and you want to also exploit the opportunities in there. So you've got two elements that you're trying to capitalize on. However, finding a compromise never gets old. It's a very difficult problem to figure out the balance between exploration and exploitation. Because let's say some of the rewards don't just exactly come now. You might have a reward that comes in the very future. A good example is if you study and you get a bachelor degree and then you get a master's degree and you get a PhD degree for the people like who are interested in academia, it might not really pay out in the very beginning. However, at the very end, it might pay out. Again, I would put an asterisk there. Take it with a grain of salt. However, what I'm trying to say here, you can exactly do a lot of work and then it can pay off at the very end. So this is what we're calling exploitation, basically. So it might not really pay off now. It can pay out after a while. But you can have a thing that can really pay out in the very short term. A good example is when you get out of university, let's say, and you pick up a job, you get cash directly. So you don't have to wait for that period before you start getting cash in your wallet. And so this is a short-term gain. However, you did not really explore that much. And so you're going to be in that position where you did not explore the environment that much and you're just exploiting as you go. So this is a compromise that a lot of people have to think about when we were doing this, especially within game development. So one thing that I forgot to talk about is the idea of reward. So as you do good, as I said, in the environment, you get rewarded. And so you go and also do more work on that environment. Yes. And so you exactly know that your choices are good. Okay. So this is one of the things that I talked about here. And when we're talking about reinforcement learning, the way we do this is very easy. So as a game developer, you have to use what we call the reward function. You set up the reward function and you just tell the game AI to look at something and to try to increase it for the sake of example. So if we're talking about Tetris, which is an easy example to begin with, we can tell the AI agent, try and explore the environment, try to do as much as possible to increase the score at the very top. So the game AI is just going to try to do a lot of stuff. They're going to go through trial and error in order to really maximize the amount in the score. So this is what we call the reward function, which is really, really important. And then you can just let it loose. You can just allow the game AI to experiment, fail, do multiple things until it gets to that sort of, ultimate map of how it can traverse the world and do, what it does best. Okay, so this is a good example to show how reinforcement learning works. So this is the game of Breakout, as you can probably tell, and we have a pad at the very end, and we have multiple, we have ball, basically a ball, and you're trying to, basically take all of the items in the very top. Now, when we have reinforcement learning, the machine is going to learn on its own. It's going to go back and forth. It's going to try to explore, to have the ultimate strategy, the ultimate tactic, to go and have everything done in there. So a really great example. And with reinforcement learning, the idea is you want to expose the game AI agent to as much as possible in terms of experience, and you want to then allow it to learn on its own. So it can observe, can see how people play, and then can do a lot of trial and error until it goes to that ultimate, solution that can, it can help it to go and conquer the game. So just think about that. It's all about absorbing the experience. Also, speaking about the reward here, this is Pac-Man, and you can probably tell there the score, and you see, this is what we call the reward function. So when you're coding your AI, you're just basically telling people that, you know what, this is the score, this is what I want you to increase. That number has to go up if you want to win in the game. So the game starts by going ahead and trying, every single option in terms of exploitation, exploration, until it gets, to the maximum, amount that we can get on the score. It's very easy to set up, honestly. Okay, so if we wanted to summarize the definition of reinforcement learning, it all goes back to the ability to observe the environment and trying to play and seeing how people play, basically. So you have those two methods, trial and error, and looking by experience and trying to figure out how you can do it. But all in all, the ultimate way is by doing trial and error, so you can figure out how to play on your own. So this is an example that we picked up from Unity, which is a game engine for the people interested in making games. And you will see that if we're talking about reinforcement learning, it managed, this game AI here, and we're talking about multi-agent, by the way. So it's not a single player. We have multiple players, playing the same team. You've got the blue team and you also have the red team. And they're playing collaboratively here, and they're trying to figure out the strategy and the tactic in order to work simultaneously and collaboratively with each other, which is a very difficult job to program if you want to do it on your own. However, with the reinforcement learning, they can pick up those things on their own, with as much as possible in terms of, experience and trial and error, which is really, really beautiful, if I had to summarize. So this is an example. And you also have that example here of playing tennis, table tennis. And as you can tell, it's just a matter of putting them on the ground, giving them exactly, let's say, the scores you can see in the very top there, and then you allow them to experiment on their own to figure out the exact, the rules of the game. So there you have it. This is basically how reinforcement learning works. Now, what is funny for me, honestly, is that, in reinforcement learning, we have seen some really weird stuff. Sometimes an AI agent is going to pick up a new trick on its own that we, even as human beings, did not really pick up on their own, which is really funny. So this is a good example. So we have a company now. It used to be a nonprofit, but turned into a for-profit company that goes by the name of OpenAI, which is an organization that does a lot of work within the AI space. And this is one of their experiments. And so the idea here is that they're trying to develop a game or simulation, if you may, where the red team has to, go ahead and be as close as possible to the blue team and probably touch them, as if you catch me if you can sort of a game. And what we can see here is that the blue agents are picking up a specific, twist in here by trying to, build a sort of barrier system, a sort of fortress in order to not allow the red team to go ahead and touch them, which is amazing. Now, what is far more amazing in here is that the red team managed to come up with different ideas of getting a box, a simple ramp, and put it in next to the barrier and going on top of it in order to go ahead and touch the blue team. So this is super amazing. And all of these ideas have been picked up automatically, I would say, by the red team by just mere trial and error and picking up, what really works for that sort of simulation. So there you have it. It's a wonderful idea, and it plays like plays to really huge length if you allow it and if you have the capacity to allow the simulation to go, for a very long time. Okay, so all in all, what I want you to understand is that reinforcement learning is a great and a serious endeavor. It's not a simple thing. There's a lot of benefits that we can get from reinforcement learning, and it's a serious endeavor. In fact, I'll give you another example so you can appreciate the level of, sophistication in that sort of exercise. So there's a game called StarCraft for the people who are gamers in the house, and it's not an easy game, honestly. There's a lot of details there and sophistication. So to master the game, you have to be a player for years and years. There's a lot of stuff that have to do with the strategy of working with a team, specific tactics that you can rely on in order to win against the other team. And so one of the feats that these people within DeepMind, which is again another huge AI company, they've done is that they built an AI agent called AlphaStar, which allows them to play against human players who are really pro in the game. So you've got pros playing and you have AI agents playing against them. And because the AI agent has been exposed to, a tremendous amount of experience, it manages, in this case, it managed to go and win over, the human players in there, which is really, really superb, because you would say a game like that is going to be difficult to master by, a game AI agent. But what we can tell from here, and these people in DeepMind wholeheartedly believe in, is that when you have sufficient computational power, as we probably call compute, you will have the ability to build a very smart AI agent eventually that can win in any sort of problem that we have, in the forefront. So a lot of people will beg to disagree. However, this is a huge deal, and it can really show you here that with reinforcement learning, we can even tackle very difficult problems like AlphaStar. Yeah. This is also an example from AlphaStar, and you can see down below, how the brain works for that AI agent. You see, we have neural network activation, just like if we had those in the human brain, and the observation on the very left. This is exactly how it sees, the environment, and then it can take the actions here. And what is so funny and cool in the same time is that even the AI agent can somehow predict, the chances that it's going to win. You can probably tell. So in this example here, it's very confident it's going to win in this game, and it's far more confident in winning, rather than just making a draw or losing the game. So there's a lot of power in reinforcement learning, a very wonderful field, to be honest. Now, reinforcement learning is not only solely exclusive to games, even though I want to mention here one really important thing, and that is normally games are the perfect test bed for those reinforcement learning experiments, because you have a sort of artificial place where you can have a simulation of some sort, and without really going to the physical world. A good example is this experiment that was done by OpenAI, and this is what we call dexterity. So the idea is these guys at OpenAI had the problem of teaching how to flip a cube, as you can probably tell, with a human, like a human hand, sort of a thing, like an artificial hand. And we as humans, we take that sort of a thing taken for granted. Honestly, we take it hugely like for granted, because it's just an easy thing to go and play with a cube in our hands and really play with the location, move it around and do all sort of things. But if you're trying to teach the same sort of skill to a robot, you're going to understand how difficult that sort of a thing is. And so what these people have done in OpenAI is that they relied on reinforcement learning in a digital world, in an artificial simulated world, we can call it a game, and then it picked up those nuances on its own. As you can probably tell here, finger pivoting, specific movements with the fingers in order to exactly change the orientation of the cube, and you can also slide it by playing with certain fingers. So all of these core skills are now being picked up by the machine using reinforcement learning, which is a super wonderful thing if you think about it. So those nuances that we picked up as human beings can also be taught to robots when we have sufficient compute. Now, a lot of people think about reinforcement learning as a waste of time because you're spending a lot of compute, you're just doing a lot of computation, a lot of trial and error until you get to that stage. However, biologists really beg to differ because their argument is evolution paid the ultimate price in making you what you are currently. Without getting into the specifics of how religion looks into this, but in terms of science, they're saying that with evolution, our kind, our species have paid the price of doing the trial and error. So we have done the compute part, and then we are currently in the ultimate shape where we're leveraging on all of our experience that is baked within our DNA. Now, I'll leave you with that thought, and it's up to you how you want to make what you want to make of it. But there's a lot of resemblance to how things really work out, and the real reinforcement learning space. Another thing is also the same company, DeepMind, worked on a project called AlphaFold, which is a very difficult problem. Now, if we're talking about proteins for the biology people who are interested here, you would know that proteins are an essential part in human biology. And one of the most difficult deals ever is by having a sequence of what we call nucleotides. For the people who are interested in the biology, if you have the sequence of the protein, can you really draw it in a 3D shape? You might wonder, why would that be super important for us to begin with? Because the reason is the 3D shape of the protein has a lot when it comes to figuring out if a disease is going to happen, or if you can really create, let's say, a vaccine, or you want to do that sort of a thing, especially within biology, figure out how diseases work, try to solve some of the issues in biology. And so the 3D shape of proteins is such a tremendous deal, and it is a very difficult issue as well to begin with. So with AlphaFold, their version, the second version, they managed to really build a reinforcement learning system that can take the sequence of the protein and draw it in 3D. So what you're seeing here is that the green, I think, or the blue is the predicted shape in 3D against the real ground truth shape. As you probably can tell, there's a lot of resemblance. So they're very close to each other. In fact, GDT is the scoring system that we're using. So GDT starts from 0 all the way to 100, and the closer you are to 100, it means that you are super close in terms of predicting how the 3D shape ought to be, in terms of basically 3D shape, as we said. And so these are really huge numbers, and this has never been the case in the last 70 years. So we're going definitely in an awesome place of leveraging machine learning and reinforcement learning, things that started with game development all the way to being used in proteins and such. Okay, so I'm gonna touch on those points before I go of how you can really start getting your hands with reinforcement learning if you're interested. So there is a package by Unity, and if in case you were wondering, Unity is a game engine being used by game developers who are doing their simulations, doing their own games, and there's this package, as we said, that goes by the name of ML agents, and it allows you to use reinforcement learning without being an AI researcher. So you don't have to be a tech savvy person with an AI, or you don't have to understand the full scale of artificial intelligence to get your hands on reinforcement learning with your games. So you can even begin to build AI agents for your games, without hard coding the code, hard coding the AI logic, as we said. Instead of leveraging on heuristics, baking the rules on your own or from your experience, you can also just use ML agents and allow the agent to figure out how the game works on its own as you play with it as a human being. So this is super great, and it allows people to do it. Now, it is fair to say that Unity itself what it does is that it leverages on the on Python API. So I'm not sure to which extent you guys are experienced with artificial intelligence or machine learning, but TensorFlow is a framework for artificial intelligence, specifically deep learning, and it runs on top of Python for the people interested in Python. And so when you download ML agents, what you're basically doing during the training period of teaching how the AI should play, it touches, it communicates with the Python API for the people who are interested in the tech and does all that magic in there. Now, this is technical. You might not be interested, but I just want you to understand that within Unity, the game engine, there's a lot of back and forth happening between the game engine itself and the TensorFlow stack on top of Python in order for the ML agent, your AI NPCs within the game to learn using trial and error, as we said. So for the people interested in ML agents, it's so easy to set it up by having this tech stack. Also, we have a project called Gym by OpenAI, and it allows people to go ahead and experiment, with those ideas, as we said, in a trial and error place. So this is a couple of photos from OpenAI's Gym where people can go ahead and experiment, and build experience here with their agents, whether we're talking about walking, bipedal walking with 2 legs, or by balancing, let's say, a bar, or even trying to play with momentum in order to get to the very top, which is, classical issues, classical problems that can all be solved within OpenAI's Gym. So this is wonderful. I really urge you guys to check OpenAI's Gym if you're interested within the AI space. Okay, before I go, I wanna say my very popular saying in here: in the race of business, data can either make or break your business. Now, this is really applicable if we're talking about business tasks and if you own a business, but this can even make sense. This can also make a lot of sense in game development if we're talking about it, because the idea is with more data, you can do significant work in AI. So you don't want to start a project, be it a business, be it a nonprofit or anything, without really leveraging on the idea of data, because it can really bite you back hard if you don't have enough data, if you want to jump on top of the AI wagon later down the line. So always make sure you have the right mindset and the right infrastructure and tools and knowledge to understand data, how to exactly work with it, if you have any feet that you want to chart. Okay, so that is pretty much what the session is all about. You can also check out my talks on Google. So I've done a lot of talks for Google in the Middle East. You can check them out on YouTube. I've done things on game development, game engines, how they work on the inside, how to build a software business, how to use open banking and the AI applications and interest. Well, a lot of stuff. You see a lot of work there. If you could just go to YouTube and type Ameen Altajer in English or Arabic, you're gonna find a lot of content. And yeah, last but not least, thank you very much for having me here today. I hope you really enjoyed this session. I wanted to make sure that I don't touch on technical details so I don't really alienate a lot of people. You can always reach me at ameenaltajer.com, or you can pick up on my Instagram and Twitter at Ameen Altajer, and you can check out our work at INFINITEWARE.com. So I'll open up for questions. I'm not sure if you guys want to ask questions. So if you want, please just write them out in here. If you want, just write the questions, and I can also open the mic if you guys want to talk, if you want to share your thoughts. Let me see if I can do that here. Okay, let me see. All right. My pleasure, Mariam. I hope you really enjoyed it. Okay, let's see. Okay, yeah, so I just did that choice where you can unmute yourself. My pleasure, as a dean. If you feel that you want to ask something, we have 3 or 5 minutes. You can go ahead, and I'll be more than happy to shed some light, on the technical details of AI, machine learning, or even other stuff. Please go ahead.
Yeah, can I ask a question, Mr. Ameen?
Sure, Ali, go ahead.
Yeah, so if you just guide us, for example, if there are some courses that we can take them for the as a developer, like in Udemy or Coursera or any other platform that we can take some courses
Okay.
that will help us?
Which
Thank you.
exactly, what exactly you're talking about? Is it game development or AI specifically?
Well, in AI in general, to get like sense of what AI and build
Okay.
from the.
Yeah,
Thank you.
sure. So, no worries. Always a pleasure. So there's a course by a gentleman called Andrew. I'm just gonna put the name here. So there's a
I
huge.
think the Andrew in Coursera, right?
Yes, exactly. So this is a very
I
popular
took
one.
for.
Yeah, there's other ones that I'm really okay. So Google themselves on YouTube, they have a lot of talks on TensorFlow. Okay, there's a series on, and if you're interested and you have the cash for it, there is a website called Pluralsight, and we also have LinkedIn Learning. So those websites have a lot of content on TensorFlow, and I'd really urge you to start with TensorFlow because TensorFlow is a Google product and it has a lot of, I'd say it has a lot of, backing from Google. So you're in the right spot at least. And yeah, so let me just think about it for a second. But even in machine learning, there are a lot of fields. So you can be interested in NLP, natural language processing. You can also be interested in computer vision. Every one of those domains has different experiences you can pick up on. But I would start with Andrew Ng, the one on Coursera, and then read the TensorFlow, look at the TensorFlow uh, tutorials on Pluralsight and LinkedIn Learning. There's a lot of content to cover. Okay, who do we have also here? Anybody wants to ask any question? You guys? Gaming, game development, AI. Don't be shy, guys. The floor is all yours.
Well, if no one want to ask you, I can ask another question.
Go ahead.
So that will be my last question. Don't worry.
Don't worry, go for it. That's fine.
There's like, okay, those are, for example, many places they provided the courses, but if you want to go in industry, they prefer, for example, a professional certificate, or even the courses will do the job, or some of them maybe they, if you have, like Microsoft, they have Azure AI and machine learning. So are those helpful, or what do you
Yeah.
think?
So, okay, here's the thing. You have a full stack if we're talking about machine learning or AI in general, okay? So you have things that can span the low-level stack, things that touch on Python aspects, maybe the C++ aspects, how to work with TensorFlow, and these are very fruitful. So being in that space is going to grant you a lot of understanding and power, within the ecosystem of machine learning. But if you go up the stack, you go up and you work with cloud services like Microsoft Azure, SageMaker by Amazon, AWS for the sake of example, you're going to work with the interface and you're going to work with the stack, but in a very superficial level, I'd say. The majority of the work happens really with the, preparing the data, building the model itself, and doing the whole thing. But all in all, the idea is you want to scratch all of those parts, all of the full stack. So the stack at the very beginning, like at the very bottom, sorry, and at the very top. So you want to learn the math behind it if you're really interested in becoming a researcher. One easy way to pick up is what I call Keras. So there's this library, Keras, which is now part of TensorFlow 2.0, by the way. So by learning TensorFlow 2.0, it is so easy to build an AI system, let's say for a game or something, with just 7 lines or probably 10 lines max. Can you believe that? It's so cool. And so understanding how to use it from a code base is cool, but the more you understand, you want to go deep and understand the math behind it so you can understand the quirks and the twist behind, that tech stack. So fruitful, just for me to finish, my answer here, yes, you can go to cloud services, but I would prefer to go down so you can at least, get your hands dirty and understand how things work. Okay, Fatma, thank you very much. My pleasure. Your question is, how can we use AI in marketing, especially for someone who wants to specially answer in marketing? Exactly. Okay. So if you're interested in marketing, as I said, there's a book called business, no, it's called prediction machines. It's called prediction machines. I just wrote it there. You can read it if you want, which touches on the business aspects more. But I would say you don't have to get your hands dirty with the code. Just understand how to deal with data. Any literacy spanning data is really important. You would probably need to understand how to clean the data, before giving it to the next person in the pipeline, most likely a machine learning engineer who's going to take the data and use it in their model or so. But understanding the expertise, the subject matter expertise is really important in knowing the tools that you can probably tell. In marketing, I'd say, yeah, probably just handling the data for now. If you want to get your hands dirty with the tech, I really urge you to pick up, a book on TensorFlow 2.0. Okay, so I'll tell you what. No worries. If you have programming experience within Python, there's a beautiful book called Deep Learning with Python by a gentleman called, Charlotte, I think Orleans, something like that in French. Yeah, I think something like that. You just get right the name of the book. So before you read that book, you want to make sure you understand Python. If you know Python, pick up that book. You're going to understand how things exactly work from the very beginning. It's a very brilliant book. But if you're interested, as I said, try. I mean, if you don't have, let's say, the time or the attention for text, you can directly look into videos that can take you from the ground up. Okay, you're in digital marketing field, and I think, if I understand, yes. There's another book called Life 3.0 for the people who are interested in knowing the implications of AI in life and everything. It's more into philosophy / I would say business use cases. But if you're interested in the business use cases, look on their own, you have prediction machines. But yeah, pick up, those business cases, try and understand the literacy first about machine learning and AI before thinking about going deep with the tech itself. If you want to pick up a language or a framework like TensorFlow or Keras to get hands-on stuff. My pleasure. All right, any last question? We have 2 minutes to go before we scratch the 1 hour mark. Any question, guys? Let's wait for 60 seconds and then we call it a day. All right, then. Let's see. A few more seconds to go. Okay. Okay, then. So I'll tell you what. This has been a great pleasure for me, honestly. I had a wonderful time. Thank you so much for your questions and your interest in making sense out of game development and artificial intelligence. Again, you can reach me at my data here, and have a wonderful day. I'll see you soon. Bye-bye. Thank you so much.